We've had functions for a very, very long time, almost since the beginning of the days of JavaScript. Now, arrow functions are relatively new. They were added in the past few iterations of the JavaScript spec, and what they do is to introduce an abbreviated syntax to allow us to simplify how we write functions. So instead of writing it in more characters and more code, we can do so in a more compact way. And when beyond just the syntactical shortcuts you get with arrow functions, they also have a different, more sane way of dealing with this, and they also have a few more tricks up their sleeve. We'll dive into all of this as we look at arrow functions at a very high level, and then we start going deeper into all the complexities that they expose and simplify in many areas. So let's start with a traditional function, and the way we're going to look at it is by starting with the function expression, where we have a function that is assigned to a variable, and it does typical function-y things. So here we have a function called laugh. It returns some text, and the way we can use it is by just calling laugh and using the parentheses to invoke it as a function. So pretty straightforward. If we had to turn this into an arrow function, there are a few basic steps that we need to take, and those steps will vary depending on how complex our function is, but we'll start with the more basic function we have now, turn it into an arrow function, and then walk and look at some of the more interesting details we'll see there. So the first thing when using arrow functions is we can get rid of the function keyword. Don't need it. And for braces that are in part of this function, especially if it's a single statement function like this one, we can remove the braces as well. So we need the opening brace, no need for the closing brace either. And the last thing is if what this function is returning is pretty easy to imply and not have multiple statements that could be doing something, we can remove the return statement as well. It's unambiguous in this case, and what our function is doing is it's returning the words haha, haha. So therefore, the return statement can also be omitted. And now all we need is the magical arrow characters themselves, which is essentially the equal sign and then the less than or greater than bracket. I forget, is that greater than? It is greater than, yes. I could be wrong here, but it's the mouth of it opening and facing left. And whatever that is what it is, but the equal combined with that is the arrow function itself. So when we take our laugh function in its traditional form and turn it into an arrow function, it will look a bit like this. Notice that instead of having 3 lines and a bunch of characters, we're able to simplify it greatly by just having it be parentheses, the arrow itself, and then a value that we are returning. And the nice thing is the way we call this function, though, does not change. So the way we called laugh as part of our console.log statement is exactly the same way as it was before, which makes it a little easier if you want to migrate a part of your code base to use arrow functions. Any function that gets called does not have to be rewritten or modified. So just to summarize what just happened here, we got rid of the function keyword, we specified an arrow, and that arrow lives between the parentheses and the function body itself, what our function is doing. The curvy brackets can be removed, especially if our arrow function is just a single statement, and the return keyword isn't needed if it's obvious what the function will return. And we'll look at cases where all of these things are up for debate, where it's not going to be obvious what the function is returning, nor is our function going to be very simple, which is a single statement, which means the brackets will need to be there as well. And so the best way to make sense of all this is to actually just look at some code and look at some examples of how we will do this. So here I am in Visual Studio Code, and this is the same function we saw earlier. Let laugh equals function, return some string, and we do console.log, and it prints haha. So to turn this into an arrow function, all I need to do is first remove the function keyword, add the arrow function, and then delete in this case, the opening and closing braces, and the return keyword, and then we have the same thing. So if we were to run this code, you'll get haha, haha. Now, in many functions though, we will have to pass in an argument. What happens to our argument in these cases? Well, what we do is we specify the argument as part of what goes inside the parentheses themselves. And so let's say we just have, like name and ha plus, or actually space plus name. And so if I were to call laugh and then have this be Zoidberg, the classic character from Futurama, what we'll see is a ha and Zoidberg printed out on screen, which is pretty common as you would expect. Now there is one interesting detail to note. If our function is taking only one argument, we can actually remove the parentheses. So we can actually do let laugh equals name, arrow function or arrow characters, and then this will print out ha Zoidberg exactly the way you'd want it to. And so I'm going to keep it in for now because let's say we have two arguments, first, last, then we need to bring the parentheses back again. It only works if you have a single parenthesis, and you can do plus first, plus space, plus last, and then you get the same exact behavior you might have had before, where if we were to call this one laugh, and the first name being John, yes, Zoidberg's first name is John, it would be ha 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 ha, and then John Zoidberg. So you can kind of see how this maps to how a traditional function would be. And just for kicks, if you were curious to know what this would look like as a more traditional function, it would just be function, first, last, add the bracket back in, take all of this stuff, put a return keyword in front of it, and print it out. So you can see how we can quickly go from arrow function to traditional function very, very easily. So I'm just going to undo this so I can go back to what we were trying to do earlier. And then the other part is we talked about the curly brackets. Do we need one or not? And so let's go ahead and take another example where I'm going to literally call it another example. And this is going to be an arrow function. And what I'm going to do here, though, is I'm including the brackets here because what I'm going to have is two statements. So console.log, hello, and then console.log, everybody. And so when this runs, because we have two statements here, we need to ensure, I forgot the arrow, very important. We need to have the brackets here because if you remove it, it doesn't really make sense anymore. It has to be only one statement to get rid of all of those things. And if we were to just do console.log and do another example, what will get printed out would be hello everybody in its own lines. So I'm not gonna show that, but you can see what that would essentially be. Now, the other thing is we talked about the return character. In this case, there's nothing to return because our function is not really returning anything, but we could have it so that let A equals hello space, and let B is another variable equals everybody. And then if we were to return this, it would be return A plus B. And what we can do now, if we call another example, is we'd see hello everybody printed to the screen. And because there are two statements here, and there's no implicit return assumed, so we need to have an implicit return statement to call this out specifically. Now, in this case, we've talked about situations where we have parentheses or don't have parentheses, we have brackets, don't have brackets, have return or don't have return. The opposite also holds true as well. Nothing forces you from having a very simple expression, an arrow function, that has all of these things always by default. So for example, if you go back to what we had earlier for let laugh, we can actually do let laugh, arrow function, bracket, and then return ha 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 ha. And this is completely okay as well. Yes, it is more verbose, but that's consistent in some way. So if your preference is to not have to deal with when do I go one line or two lines, or when do I have a return or not have a return, you can always do this as well, because as we'll look into a few moments later, there's more to what arrow functions bring to the table than just a compact syntax. They actually have some other niceties that make it all work really well. So let's look at one more example. I'm going to copy and paste this in here just to save you some time. And so in this example, I'm going to have a function that allows us to calculate the diameter of pi. And so notice here that we have the function is called calculate diameter. It is set to an arrow function. Notice what I have defined as the argument variable. So we can have this radius as the argument, but one of the nice things we also have in JavaScript right now is we can initialize an argument by default if it hasn't been provided by the callable function. So in this case, we're just calling radius equals 1, and then we have the value of pi. Instead of using math.pi, the hard-coded constant, I'm just specifying 3.14159, and the diameter of a circle is 2 times the pi times the radius, and returning the value. And so you can see all of this. When you console.log it, when you have a value of 4, you get 25. When you call it without an argument, because radius is by default set to 1 if it hasn't been specified, we get 6.28, which is really nice. And the part I really want to just emphasize here is that a lot of the niceties you get with functions, such as spread operators and also being able to specify the default argument value, you get those with arrow functions as well. So even though the syntax might look a little more compact, it doesn't mean you're losing out on a lot of the flexibility. And so with that, let's go to our slides for a moment and look at a few more things about arrow functions before we wrap it up and call it a day. So here's calculate diameter one more time. So you might be wondering, when do I use arrow functions? They seem pretty useful and they seem to add some value, or what traditional functions do, but they're also optional. So what's going on here? And so the thing is, they provide a complex syntax, and you don't have to use them if you don't want to. And that's a nice thing about it. And the only exception, of course, is that if you're working on a shared code base with other people, you want to be consistent with what is currently being done, whether it's through your documentation or the convention that your team is following, or even a style guide. There are a few very popular style guides for JavaScript that have very strict guidelines on how arrow functions should be defined and when to include curly brackets, when not to include curly brackets from a stylistic point of view, as opposed to a accuracy point of view. And so you want to be consistent with what your team is doing. If you're working by yourself and you're basically soloing it, great, do whatever you're happy with. If you're working with other people, you probably want to be consistent and be a good team player. The best time, though, to use arrow functions is whenever you have to have an inline anonymous function. So for example, in this case, you can see I have an event handler for click, and what I specified is a function that essentially takes the event argument ID value multiplied by 100 and returns some value back. So this is an inline anonymous function, and if you were to turn it into an arrow function, it looks a bit like this. So event handlers are a great place where arrow functions are useful, especially when we're not going to be reusing that function over and over again. It's only going to be used in this case by the click event, and so you're in a good spot. Similarly, timers have a good area for them as well. Like I said, interval, for example, takes a function as an argument for where you can specify what happens each time the interval ticks. In this case, we just have a log statement that says tick, and we were able to use an arrow function to simplify things very greatly. Now, there's another huge area, though, where I absolutely love arrow functions. Even if I don't care about the syntactical conveniences it brings, it's how it handles this. So take a look at this code, and I'll walk through a little bit of it. We have an object called counter, has two properties on it, initial and interval. And inside of it, we have another property called start counting, which is a function. And inside this function, we have set interval. And this set interval is a function that increments the value of initial, which is at 100, by 1 every 1000 milliseconds or 1 second, which is specified by this dot interval. Now, when we do console.log set initial, the expectation is that this set interval will be calling this code every 1 second, 1000 milliseconds, and will be printing out the value of this dot initial, which means that it'll go from 100 to 101. So what we should see printed is 101, 102, 103, 104. Every second is going to be incremented. That is at least the expectation. Now, what actually happens though is you get an NaN value. And this is an example that I go into much greater detail in both the article and video called Making Sense of This and More in JavaScript. So I'm going to be a little bit more brief here. But like I mentioned, what's going to get printed is NaN, not a number. And the reason for it is this. One of the things that functions bring to the table is that they redefine the value of this based on whatever context they're currently being used in. So in this case, when set interval is being called and we have a function that is being defined, it is not inheriting the value of this from its outer context. It's not getting it from start counting. It's actually getting from the window object itself. So what's actually happening is we're trying to increment the value of this dot initial, which is the same as incrementing on the window object, which we know does not have an initial property. And so incrementing it results in an error. And this is a common problem with functions that are defined using the function keyword because of how they redefine this to suit the context they're currently in. Now, when we turn that function into an arrow function, where we just went from the function keyword and just replaced removed function, added the parentheses and the arrow characters, the behavior works fine. And the reason is this. Arrow functions do not redefine their own value of this. In fact, they inherit this from what's known as a lexical scope, from wherever it is currently being used in, which in this case is start counting itself. So whatever the value of this is where start counting is operating in, that is the exact same value of this that the function has at interval will have as well, which allows us to have working code without doing some of the other techniques that I talk about in the other article and video, where you might be having to redefine this and pass it in as an argument. You might see the variables that equals this often show up, or you might have to use the bind keyword and force the value of this to be used in this particular context, all of which you can avoid by using an arrow function. So the big thing is that beyond abbreviated syntax, arrow functions don't redeclare this. They inherit the value of this from their lexical scope. They also have no constructor or prototype properties. So if you're familiar with the idea of having a value equals new and then function, you can't do that with arrow functions. So keep that in mind. And they also don't have any support for bind, call, and the apply method. So if you rely on those as part of your code, you need to revisit whether you want to use arrow functions appropriately or not. And so with that, here's a lightning fast overview of how to use arrow functions, what makes them really cool, and how they are an improvement over the more verbose syntax you might see with function expressions. But beyond just the syntax, having the ability to not have to deal with the shenanigans of this, not having to deal with some of the quirks of the constructor and prototype properties you might have, or call, bind, and apply. So arrow functions have some niceties going for them that if you have the opportunity to use them, or if your team insists on using them, you now have enough of a technical understanding of how to either convert your existing code to use them, or to write new functions that rely on the capabilities arrow functions bring to the table. And so with that, if you have a question, best place is to post on the forums at forum@krupa.com, where I and others would be very happy to help answer any question you might have on web development. You can subscribe to the Krupa newsletter, where a few 100,000 people just like you get regular updates on web development topics that I think are exciting and interesting and insightful for you to be up to speed on. Follow me at Krupa on a bunch of social networks. Twitter is the one I spend a lot of my time on, but I'm also on the other usual ones. So definitely follow me at Krupa, which is usually pointing to me. But if it's not, find the version that is me, which is either Krupa C or something on Instagram. But you'll find me at Krupa almost everywhere. And lastly, if you enjoyed my way of teaching JavaScript, especially in this case, arrow functions, I cover a full end-to-end examples of how JavaScript can be used for beginners in my book, JavaScript Absolute Beginner's Guide. New editions are regularly coming out, and so definitely check it out if you want a more visual, more paperback or digital version of it on Kindle that you can use to get a much better understanding of JavaScript. I also have a bunch of other books on other topics like Canvas, arrays, animations, and React, so check those all out. All the links are at the description below. And with that, I will see you all next time.